Alright, so next topic is DOM. DOM stands for Document Object Model. So these are the set of topics we are going to cover. So we are going to see the characteristics of DOM, and then we are going to see a node tree and node types concept, and then we are going to see Java interface support for supporting DOM. And then we are going to see the things that you can do with DOM, like a traversing, manipulation, and creating a new DOM and writing out. We are not going to actually cover all of this, but these are all possible operations that you can do with DOM compared to JAX. Okay, and then benefits of drawbacks of DOM. So the benefits of drawbacks of DOMs are exactly the opposite of JAX. Okay, and then JAXP 1.1, as I said before, supports JAX and DOM underneath. So DOM characteristics. So in DOM, you are going to access XML document as a tree structure. In JAX, you are accessing XML document as a stream of things. But in DOM, you are going to read the whole XML document, and internally it constructs in-memory structure representing the tree, representing XML document as a tree. Okay. So composed mostly element nodes and text nodes. Okay, and once you have in-memory structure of that XML document, you can walk the tree back and forth. Okay, so again, this is a difference from JAX. JAX, you read it once and then node is gone. In the case of DOM, you actually have a tree structure in memory, and you can traverse it, you can go back and forth, and so it's pretty powerful way of actually accessing the elements of your XML document. Now the downside of DOM is it requires larger memory requirements if the file is big, okay, because it has to read the complete document in memory, so it might require large memory space if XML document is large. So you want to use DOM when you have a need to walk and modify the tree. So this is actually answering a question. This could be an answer to a question of when to use JAX and when to use DOM. Okay, so when you have a need to walk and modify the tree, then you do not want to use JAX. In that case, you want to use DOM. Okay, when you do not have a need of walking and modifying the tree, then you use JAX because that's faster. Okay. So this is the DOM operational model. So DOM parser read XML document, and then it actually create a tree structure in memory representing that XML document. So this is the root node, and this is the child node of that root node, and things like that. Okay, DOM node tree and node types. So XML document is represented as a tree, okay, internally, and tree is made of nodes. And in XML document, everything is represented as a node, and there are 12 different node types. And of course, nodes can contain other nodes depending node type. So if you have element node, it's highly likely that it contains a child node. Okay. However, if you have an attribute node, the attribute node has a text node. If you have a comment node, yeah. So depending on the node, it could actually have the multiple the hierarchical structure. So these are the set of node types: document node representing the whole document, and document fragment node, element node, attribute node, and text node. So the most important node types are document node representing the whole document, and then element node representing each element, and attribute node that representing an attribute, and text node. Okay, so everything else is kind of noise in a sense. Okay, so as long as you know the concept of these 4 important node type, which is highlighted with this star, then that should be good enough. Okay, so DOM tree hierarchy. So document node contains everything, and it contains one root element node, and then it does have one or more processing instruction nodes, and it might actually contain some comment node, whatever. And now an element node may contain other element nodes, and it could contain one or more text nodes, and it could contain one or more attribute nodes as expected. An attribute node can contain a text node. Okay, so let's see what we want to do is, we want to actually see how we can use DOM, reading this XML document. Okay, so it's a very simple XML document. This is in fact the fragment of the XML document that we played around yesterday, right? So this is a people element as a root element, and it has a single person element, and person element has name and profession child elements. So in this case, if you're representing this XML document, and if you actually parse this XML document using DOM parser, so in-memory structure is going to be something like this. Okay, so there is the XML document node on the top representing the whole XML document. Then there is the root element node, which is people. So this is the root element. And then we have person element and name element and first name element. Now, text node is considered as a child node of the surrounding element node. So in this case, this Ellen is a text node, which is a child node of the first name, and Turing is a child node of last name. Okay, same thing. The computer scientist is the text node, and it is a child node of profession. Okay, same thing with attributes. So this born is an attribute node, and this is a text, right? So this is a child node of born attribute node. Okay, so that's basically what gets constructed internally. Okay, so as you can see, text node is a child node of surrounding element or attribute. Okay, so how we are going to work with DOM using Java APIs. So how do you represent each node type in Java programs? There is actually Java interface type called node interface type, and that is the top of the Java interface hierarchy that actually represent the DOM tree. Okay, so basically we're using this Java interface hierarchy to encapsulate common characteristics among node types. So let's see examples of this. So this is node face, a node interface. Okay, and then node interface is a parent interface of other interfaces, so like a document interface, document type interface, character data interface. Now character data interface is the parent interface of comment and text. Okay, and then we also have element interface. So node interface is the top level interface of other interfaces. So the other interfaces that are provided for DOM include NodeList. So this is the list of node, named node map. So it's a kind of key value pairs, and DOM implementation. These are all interfaces. Now, the most important interface is a node interface, which is the top level interface. So it provides a primary data type in DOM, and it represents a single node in a DOM tree regardless of what node type it is. Okay, so every node has to be node interface type because this is the top level interface. Okay, which means every node should be able to access the methods of node interface. Okay, so it actually provides polymorphism. And specialized interfaces contain additional or more convenient methods. So specialized interfaces, I'm talking about these specialized interfaces, will have their own specific methods in addition to the methods provided in node interface. So let's take a look at the methods in so let's take a look at the methods in node interface. So the methods provided in node interface includes get node type, so you can get the type of the node, okay, whether that is element type or it is attribute type or text node type and things like that. You can get the name of the node, you can get the name of the you can get the value of the node, and you can also get all attributes, and you can also get the all child nodes. Okay. Not all methods would make sense to node types, however. For example, for element node, the node value probably doesn't make any sense. Okay, for comment node, calling get attributes probably would not make any sense, and it will just return null. Okay, so these are the node types defined in node interface. So element node is 1, attribute node is 2, and things like that. Okay. And then node interface also provides bunch of methods. As I said before, it does provide get node name, get node value, and get node type, and things like that. You can get the get child nodes, which is providing node list object. Okay, so this is an interface. Okay, and this is a named node map interface. When you call the get attributes, it's going to provide kind of the named node map, like a key value pairs of those attributes. Okay, it does also provide a bunch of other methods. For example, insert before, replace child, remove child, append child, and you can also call normalize and things like that. Okay. Now, DOM APIs are rarely used. As you can see, it is very, very low-level APIs, right? I mean, you are basically dealing with replace child, insert before, and things like that. So it's just very complex and low-level, and so DOM APIs are very rarely used. And there are, in fact, other alternatives which we are going to learn. The one is stacks. That's the next topic after this we are going to talk about. And later on we are going to learn what is called the JAXP, and that actually provides much better way of actually reading XML document, okay, in your Java code. Okay, so just consider JAX and DOM are just too low level, and we are actually learning these things mostly for the sake of actually getting exposed to the fact that these are available, but in production I would say you don't want to use these low-level APIs in most cases. Okay, NodeList interface represents a collection of nodes, and it is the return type of get child nodes of node interface. Okay, and this is the NodeList, and basically you can get the you can actually provide an index to get the particular node from that node list, and you can also get how many are in that node list by calling get length method. Named node map interface represent collection of nodes, each of which can be identified by name. Okay, this is the return type of get attributes method of node interface. So when you want to have a set of attributes in name value pairs, this is the interface that you could use. Alright, so this is the name node map, and these are the methods you can actually call. So for example, you can get the node, you can provide index so that you can get the particular node, okay, and you can actually get the named, you can provide the name, and then you get the node and things like that. Yeah, just kind of understand that these kind of methods available in this interface, and you don't really have to remember anything of any of this. Document node is a root node representing entire document, and the child node could be one root element node, optional document type node, and processing instruction node, and comment nodes, and things like that. Document interface so document interface is actually providing several providing factory methods for creating other nodes like elements, text nodes, comments, and processing instruction nodes, processing instructions, and things like that. And it also has a method to get the root element node as well. Okay, so if you need to actually add a node, if you want to need a text node, for example, if you need to actually add a text to a particular element or something like that, you have to create a text node from the document object, and then you're going to insert it. We are going to see example of that in a few minutes. So this is the document interface. Okay, so again, document interface extends node, right? Okay, so this is one of the node type. So these are all create methods. So here you can create attribute. Create attribute with a namespace. Okay, so you provide a namespace URI and a qualified name, and create element, and create element with a namespace. And then this is the get document element, that basically getting the root element, and get elements by tag name, get elements by namespace. Okay, all right. All right, so this is an example. So if the node is the document node, basically we can get the root node, we get the document object, right? Okay, and then we can get the root element of that document node. Okay. Element node representing an element, and it includes starting tag, ending tag, and content. So element could have a child node types, which could be other elements nodes, or it could be attribute nodes, and it could be text node. Okay. So this is the element interface. So you can get the attribute, a single attribute providing a name of the attribute, or you can set the attribute. You can remove attribute, and you can get the so you can get the elements by tag name. So basically you can get the elements by providing the tag name, and you get back the node list. Okay. So this is like what you see in the JavaScript code. Okay, so element node using methods of node interface. So you can get the name of the element name by calling get node name. You get the element name, and you can call get attributes, and it will return named node map. And you can get the all child elements by calling get child nodes. Okay, and it returns the node list. Okay, kind of obvious. Okay, so this is example code. So here we can get the node name of that element, and then we can get the all attributes of that element, and we can get all child nodes. Okay. Character data interface representing things that are text. Okay, so it is a super interface of text interface and common interface. So this is a character data interface. So you can get the data, set the data, and append data. So you're basically having methods for dealing with strings. Okay, so moving forward, DOM operations. So you can traverse the DOM. So you can actually start from the root element, then you can traverse it. Okay. You can manipulate the DOM. So you can append the node, you can remove node, you can modify node. You can also generate a brand new DOM in memory. So instead of reading XML document, you could create the DOM, and then you can write it out as an XML document. Okay. You can also serialize DOM. So traversing DOM. So basically there are a bunch of several interfaces: document traversal, node iterator, node filter. You can actually kind of filter, meaning you don't want to actually traverse a certain set of nodes or something like that, and tree walker. So again, these are the interfaces that you can use. They just provide a slightly different APIs for traversing DOM trees. Okay. All right. So we're not going to actually go through those APIs. Okay. Just understand that there are traversing APIs. That's all we need. Manipulation of DOM. Here we're going to actually go into a little bit more detail. So we can create a brand new node, we can add a child node, we can remove a child node, change a value of a node, and normalizing text to node and things like that. So this is an example code for creating a new node and add a child node. Okay. So here we are going to call create text node method providing some text. Okay. Again, you are using document object as a factory class. Okay. So you get the text node, and then you are going to add text node as a child to that element. So again, this is a very clumsy and low-level API for adding a text, right? Okay. So again, this is very this is not the best APIs to use to add the text into your element. Okay, but these APIs are available. Remove child node, basically called remove child node and providing node object. Okay, so moving forward, benefits and drawbacks of DOM. So again, the benefits and drawbacks of DOMs are exactly the opposite of SAX. Okay, so you use SAX when you cannot use DOM, and you use DOM when you do not want to use SAX. Okay, all right. So benefits of DOM. it provides a random access manipulation of XML file because it has in-memory representation of that XML document, and it can actually access randomly. JAX, you cannot do that. Okay, so when you have a need for random access manipulation, then you want to use DOM instead of JAX. Okay, DOM can be created from scratch or from an existing file, can be edited in memory. So you can typically you are going to read XML document as a source, and then you can manipulate, or you can manipulate and change and remove and things like that. Okay, or you can create one in memory. Okay. The drawbacks of DOM. So these are the drawbacks of DOM, meaning these are the things, these are the reasons why you do not want to use DOM and instead you want to use JAX. So large documents could be problematic in DOM since the entire document has to be read in memory. So before you get your hands on, okay, all the XML document, the complete XML document has to be read in memory, and the tree structure has to be completely constructed before you can have an access to that document node. Okay, so if XML document is really big, then you might actually encounter memory problem. Okay, so performance could suffer using DOM with large document or limited memory availability, which is just what I just talked about. And no standard support for reading documents or writing DOM models out to files addressing in levels. Yeah, so this is actually addressed in DOM 3. Okay, so this is not an issue. I should actually remove that. Okay, so JAXP DOM support. Okay, so this is the same slide we saw in JAX presentation. So as I said before, the JAX and DOM APIs were available even before JAXP. Okay, however, creating parser API, creating parser object APIs were not standardized, meaning different parser implementation, even though they are same, even though there are multiple JAX parse implementation, each of those JAX parse implementation has a different way of creating parse object. Once the parse object is created, then the APIs are the same, regardless of the implementation. Okay, so creating parse object API was not standardized until JAXP. Okay, so now JAXP provides the portable APIs, including creating a parse object, and also it includes a JAX and DOM APIs. Okay, so any application written on the top of JAXP, they are all portable. Okay, so JAXP also provides pluggable architecture, so you can actually plug in different DOM parse implementation or different JAX parse implementation. Okay, and while your application portability is preserved. Okay, so the parse implementation has to provide implementation of JAXP interfaces. Okay, so JAXP implements DOM interfaces. DOM does not specify how a tree is created in memory or how its content is obtained. DOM does not specify how a tree can be navigated and manipulated. DOM parser must be must be instantiated explicitly using vendor-specific routines. So basically, you can think of JAXP as a standard Java APIs for JAX and DOM implementation. So that's pretty much all I want all you have to know. So this is the code using JAXP. Okay, so you create document builder factory object first, and from the factory object you can call some APIs like a set validating true, meaning I want to have a validation to be done, and then you're going to get the parser object. So this document builder is representing parser, DOM parser object. Okay, so from the factory object you get the DOM parser object, which is represented by document builder, and then you can start the parsing, providing the location of XML file that you want to parse. And once in-memory structure is completely constructed in memory, then it will return document object to you. Okay, so once you get the document object, then you can get the root element, and from the root element you can get the child elements and all that stuff. Alright, so that is the end of the presentation. So let's take a look at the lab documentation. So lab documentation, so in this case we have a very simple exercise as well. It's pretty much similar to what we have done in JAX. We are going to just open DOM sample application, and it's going to just construct the tree. So it starts from the root document, node name is document, and then for each element it will just display the node name and the URI, okay, and locale, okay, and then attribute and text, and then so basically it will just read the tree, and then it will just display each node. It's basically doing a traversal. Okay, so let's actually do that. So you are going to File, open the project, and go to so this is probably the same DOM project, but just go to the JAXP DOM APIs here, sample NetBeans project, and select DOM and open project. Okay, and then you're going to run it. Okay, so it will just display it's just traversal. It traverses the whole XML document, okay, and then it just kind of display information about each node. Okay, so if you take a look at the code is again relatively simple. So I'm gonna actually show you this code first. So this is the step 1. So you create document builder factory object, and you get the document builder factory object first. Okay, and if you want to actually have a namespace aware, then you can set it to true. This is another option that you can set. Okay, and you can do the validation. Okay, and step 2, you are going to now create document builder. This is document builder is DOM parser. Okay, so you're going to call the get document new document builder method, and you get the document builder object, which is a parser. And then you can also set event and error handler before parsing. Okay, and then what's important is step 3. So we start the parsing, providing the name of the file. Okay, so the name of the file is again the same book catalog.xml file, and you got the document object. Okay, and then we are basically providing document object to this new DOM echo method. Okay, DOM echo class, and DOM echo class has an echo method. So it basically going through this document node, and it will just echo each node every time. So that is basically this code. This is the DOM echo class. DOM echo class has this echo method. Okay, and so whenever it's reading a node, okay, it's going to get the node type, and based on the node type, it will just display. If it is the attribute node, it will say attribute, and then it's basically display, and then it will just call the println common. Is actually the print method that actually display information about that particular node. Okay, so it's relatively straightforward. And whenever you have an element node, that's probably the most important node type. So here basically what we do is that we say element, and then we get all the attributes, and then we just display the attribute. Okay, so that is pretty much it. Again, I'm gonna give you guys about 12 minutes, and let's have 15 minutes break. So we will be back 45 after the hour. Okay, let's see whether recording is